everybody. So in this packet tracer here, we'll be working with the assignment skills integration challenge. This packet tracer is basically to test your knowledge on variable length subnetting. We have 3 different networks, and these networks, they each have different requirements. The staff, it requires 100 hosts and 50 hosts for the sales and 25 hosts for IT department. On top of that, there's also a guest network that will be added later that also requires 25 hosts. All right, so the first thing that we need to do is that we are going to take this IP address and we're gonna break it down to 4 subnets. All right, so over here they already indicated and put in order the way we need to go about the subnetting. So first we're gonna work with staff that requires 100 hosts and so on and so forth, working from the most host requirement down to the least amount of hosts. And that is a best practice when you're doing variable length subnetting, because you do not want to end up having overlapping in your addressing scheme. So as a best practice, you always begin with the highest amount of requirements. So let's just start with the subnetting, and I will present you a nice subnetting calculator that is really useful when it comes to this, and you cannot go wrong with this. There will be some links in the description that will take you to the videos I use to use this table, and also how to help you speed up your subnetting process, as well as a video to learn how to perform subnetting in general, and also variable length subnetting. So switching to the calculator. So right here, I already put some information in it. So we need to create 100 hosts for the staff. So the first thing I do is that, to explain this calculator, this right here, that's my block size. Let me just this right here is my block size. This right here is my subnet mask in dotted decimal, and from here all the way to here I got my slash notation. In this case, since we are given the /24, we are going to work only on the last octet. So that means that we're not going to use none of these slash notation. Okay, we're going to focus only on the last octet. So this can be erased. We don't need that. So we can just concentrate on the first 3 rows. Okay. All right. So for figure out what will be the slash notation for the first subnet, which is staff, we have to count by twos all the way up until we get to the minimum requirements, in this case 100 hosts or more. So let's see, we begin with 1 and we're gonna start counting in doubles. So we're gonna double up, we're gonna begin with 2 and we're gonna double up. So 2, 4, 8, 16, 32, 64, 128. So with this, I have already achieved my 100 hosts. So what I'll do is that I will draw a boundary right about here that will then indicate that that's where I need to begin. So, or I need to stop right here. So my block size is 128. My block size is the number that we're gonna use as an indicator to then have the precise starting point of the next subnet, because that's where our subnet will stop and the next subnet will begin. That's what it means by block size. Staff block size is 128, the maximum. We cannot go beyond that. So because that's gonna be the next subnet, so we're gonna go here and we're gonna add that block size to whatever number we have here. Okay, in this case we only have number 0, so we're gonna add 128 to 0 and it's gonna result in 128. Now we know that that's where our next network is going to begin. Now that we have that established, we know that the broadcast for staff is going to be 127. And because that's going to be the broadcast, it means that the last is going to be 126. Then because we know that we begin with 0, the first is going to be 1. So we basically have that already completed, because the slash notation, as you guys can see, align perfectly with the slash 25 right at the top. And that is what we use to figure out what we need. Alright, moving on. We said that the first is going to be slash 25. That's it. Then the next is going to be cells. Okay. And I'm not going to write anything else because it's going to remain the same. Okay, so it's 128. We don't know what the slash is going to be because we need to count the hosts. So we repeat the same process. 2, 4, 8, 16, 32, 64. That right here is enough for my minimum requirements of 20 or actually 50 hosts. So I need a 50 hosts for the cells. So this is my boundary and this is my block size. And what we need to do, okay, is that we know the block size and we know the slash notation. We can go ahead and slash 26. Okay. Now, right after that, we're gonna take our block size and we're gonna add it to whatever number we have here. This case is 128. So 64, 128, 64, 192. So we know that our next subnet is going to be 192, and that's going to be the beginning of the network for IT department. We don't know the slash notation just yet because we need to do the count. Okay, but we already know what's going to be the broadcast for sales, which is 1 less than 192, making it 191. The last is going to be 1 less than that, 190, and the first is one more, is the next after the actual network address, which is 128. So the first usable is going to be 129. Good. That's looking good. So now we are done with sales. Now we can concentrate on IT, which is 192, we said. Okay. IT is going to be 192. We don't know a slash just yet. And IT requires 25 hosts. So let's do the math. I'm gonna clear this. And let's figure out how many bits I require to get the minimum of 25 hosts. 2, 4, 8, 16, 32. There you go. 32. So I stop, draw my boundary, and my block size is going to be 32 right here. And that's going to give me a minimum of 25 hosts. Okay. It's gonna give me more, but it's gonna be way less than if I use a flat subnet mask. That's the idea of variable length subnet mask. At this point, you guys should know exactly the idea behind variable length subnet mask is to prevent the waste of IP addresses. Now that we have the block size, we can also establish our slash notation, which is 27. And we also have the block size, so we're gonna add the block size to the network address, which is the 192. It's 224. Right, so yeah. So 224 is gonna be the next network. 224. That's gonna be for the guest network. Okay. Alright. So since we know that, we know also that the broadcast for IT is going to be 2, 2, 3. The last usable 2, 2, 2, and the first is going to be 193. And with that, we're done with the IT. Now, the guest network requires also the same amount of hosts. So we already have the math. We know that for that we need a slash 27. and our block size is going to be 32. So we're going to add that. Okay, that's way too low. Let's add that. 2, 2, 4 plus 32. 6, 5, 2, and it's still low, huh? Okay, so 2, 2, 4 plus 34 plus 32, I'm sorry. 6, 5, 2. That gives us 2, 5, 6. That means that we have already exhausted all the possible usable IP addresses out of that /24 that were given to us initially. Okay, so now let's finish up. We know that broadcast is going to be 255 because after, if we add 32 to the 224, the 224 is going to give us 256. So one less for the broadcast, 255. That's usable. 254, and the first is going to be 225. 25. Alright, so and we're done with guest. And that's it. So now we can use this information, and with this information now, we can go ahead and complete our task and apply configuration on the network devices. So let's move over to the network devices, our topology. We're gonna keep this table on the other screen. Let's see if I try to move it. Can I move it? Okay, so I guess I can move it, but it's going to be difficult to work. Yeah, it's gonna be really difficult to work. Let's see if I can move that here. Nah. Alright, so we're gonna keep it aside and we're gonna come back as we go along with the configuration. Alright, good. Let's do the configuration on devices, and we need to begin with the PC configurations. They want to statically add the IP addresses. So let's start with staff. I'm gonna go in order. So we're gonna begin with staff PC, and we're gonna statically configure both IPv4 and IPv6. We click on that. Now, they do not specify exactly the range. They do not specify if they want from the first 10, the last, or the first. So we're gonna go by default. I'm gonna use the first available IP address that I have assigned for the subnet. The first IP address is gonna be for the router. The second IP address is gonna be for the switch, and then the third, I'm going to use it for the PC. So going back to the table, so in staff, the first is going to be 1, and then the other one. So we had the first for staff number 1, and the last is 126. So the first is gonna be assigned to the router, the second to the switch, and then number 3. So dot 3 is going to be used for this PC. Going back again, let's use 192.168.0.3, the subnet mask. We said that the subnet mask is /25. Okay, so that is the /25. We align the /25 to the 128 in dotted decimal. Okay. One 192.168.0.3, 255.255.255.128. The gateway, we said we are going to use the first address, so it's going to be 192.168.0.1, and now we're gonna assign the IPv6 from the table, and this PC is going to use this address, and it's a /64, and the link local is going to be FE80, 2, or : 2. So the IP address, we're gonna paste it here, and it's going to be a 64. Okay, subnet ID. The link local is going to be FE80, 2, and the default gateway is going to be FE80, 1. As you guys can see, that's going to be the default gateway. So this is going to be the link local address for the router on all interfaces. Okay, so configuration for the PC has been completed, and now we can move on to the second PC, which is the sales network. For the sales network, we said that we want to use, where is the, okay, right here. Let me bring this over here. So for the sales network, we want to use the first, it's going to be 129 for the router. The second for the switch is going to be obviously 30, and 31 is going to be for the PC. It's a /26. So 192.168.0.1. Okay. So can move this out of the way. Alright, so cells 31/26. Okay. On 31. That's gonna be for the third. Now is at 26, and if we align this 26, we know that let me clear this up. So, okay. So, for the /26, the subnet mask is going to be 192. The gateway .0.129 IPv6 for cells. /64 link local, default link local, one. We're done with the cells PC. Okay, so we're done with that. Now IT PC, for IT, it's going to be again 196. So 193 is going to be for the router, 194 is going to be for the switch, and then 195 is going to be for the PC. It's a /27, so /27 is going to be a 224. .195. 255.255.254. 92.168.0.193. IT, we're going to use this IPv6. So there, 64. In local. And for the default gateway IPv6, 380::1. Okay, so we're done with configuration for the PCs. Now we're gonna work with the router. First thing they want us to do is configure device name. R1. Disable DNS lookup. assign Cisco and pass. So Cisco ENPA55 as the execute mode. So enable secret. Assign Cisco CONPA55 for the console. Password. Login command in order to activate that. We're going to require that a minimum of 10 characters be used for all passwords. Alright, so for that, get out of this. Security. Encrypt all plain text passwords is the next task. So service password encryption. Alright, so configure and enable all gigabit Ethernet interfaces. Okay, so but first create a banner that warns anyone accessing the device that unauthorized access is prohibited. Alright, so they want this message for the banner. Message of the day. I'm gonna get a little fancy here. Alright. Okay. Unauthorized access is prohibited. Fantastic. Alright, so there you go. Now configure and enable all gigabit Ethernet interfaces. Alright, so we need to configure each one by one. And looking at the topology, gigabit 00, gigabit 01, and gigabit 02. Alright. Interface gig 0/0 IP address, that's the one going to staff, is going to be 1, and /25, that's gonna be a subnet mask of 128. Okay. Now it's shut down. Interface is up. IPv6. address for gigabit 00. Copy that, paste it. Alright, so E80 : for the link local. Okay, we already did a non-shutdown on that. Okay, so that's for gigabit 00. Configure IPv4, IPv6. Now let's go to interface gigabit 0/1, and that's gonna be for the sales department, and the first IP address is gonna be 193, and it's a slash. Oh, the sales department, actually staff was the first. Sales department is going to be a 129, and it's a /26, so it's a 192. Okay. IPv6. The link local. And shut down. Good. Now let's move on to the next, which is going to be IT. And for IT, we said that the first address is going to be 193. The subnet mask is a /27, which align with 224. 224. Okay. That's 2. IP address 192.168.0.193. Subnet mask 255.255.255.224. Okay. IPv6. It's going to be this one right here. Paste it there. Now the link local. E80 : 1 link local. Not shot. Alright, so we're done with the configuration for the interfaces in the router. When it comes to addressing, now what else do they want? Okay, now they want to do the configuration for SSH. So for that, we need to begin with the domain name. IP. Need to get out of here. IP domain name, and it's going to be this one. Paste. Okay, good. After that, we need to generate the crypto key. And so we're going to type crypto key generate RSA generate keys modulus 1024. That's done. Okay, and configure VTY lines for SSH access. Use the local user profiles for authentication. Create a user. So we need to create a user first before we go there. So username admin1. They also want to elevate that privilege to level 15. So privilege 15 secret for the password. It's going to be admin1 PA55. Okay, now that we have that user created, then we can go to the VTY line and configure that VTY lines to accept the username for authentication. So let's go to line VTY 0 to 15, all of the VTY lines. Now we're going to specify login local to transport every input as SSH. Okay. Configure console and VTY lines to log out after 5 minutes of inactivity. Okay, so for that we need to run the command execute timeout. They say what? How many minutes? 5 minutes. Alright, so that's done. Block anyone for 3 minutes who fails to log in after 4 attempts within a 2-minute period. Alright, so for that we need to get out of the VTY lines. Alright, so now we're going to put the login block for minutes, 3 minutes, but this is in seconds. Yep. So 60 first minute, 120 second minute, 180 for 3 minutes. And that's gonna be also attempts. How many attempts? 4 attempts within 2 minutes. So 120. Good. Back to the line console 0, just to make sure that we configure the log out after 5 minutes of inactivity. So after 5 minutes. Alright. Believe that is all we needed to do here on the router. And one more thing, we need to do two things. So first, IPv6 unique address routing, so our router can actually forward IPv6 IPv addresses and route to IPv6 addresses. So now, as best practices, we also need to copy our running configuration to our startup configuration. Seems to be all right. Now we need to take care of our switches. First, we go to the switch. Configure terminal. Yep. Okay, so that's good. The switch. Configure the device name according to the addressing table. We know that that is a S1. And then configure SVI interface. Okay, so we are using default VLAN here, IP address. Now for the staff switch, we said that we want to use the second IP address, so it's going to be 192.68.0.2. Okay, so 168.0.2. Now subnet is going to be, we said that for staff is a subnet is 25. So looking at the table here, so /25 aligned with 128 for the subnet mask. Okay, and not shut. The default gateway is the next configuration. Okay, so you need to go to global config, IP default gateway, and it's going to be the first IP address for the subnet. So instead of 2, it's going to be 1, and same subnet. We don't need subnet when we are applying default gateway. Okay, disable DNS lookup. No main lookup. No IP domain lookup. Assign Cisco. Okay, let me make sure about something. 9 console 0. Yeah, I did. So let's see. Show running configuration for the console 0. Okay, so that's invalid. Okay, show okay, so console line 0. Okay, show running config. Okay. Alright. Good. Alright. So, right. Good. It's good. 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 Okay. Making sure, guys. That's all I'm doing. Double check. Always, all the time. Sorry about that, but that's the way I roll. Now, this is switch to. Alright, so configure Cisco ENPA55 as the encrypted privilege mode. Okay. Enable secret. Paste that. And then to the console, this password. So then console 0 password login, then console BTY lines to log out after 5 minutes of inactivity. Configure the console and BTY lines. Alright, so we are already in console. Okay, so accept. Now, timeout. 5 minutes. Exit. Go to line BTY. BTY 0 to 15. Repeat the same command. Okay, let's get out of here. I'm gonna encrypt all passwords. Okay. And then we're going to repeat the same thing for the other switches. Alright, so let me try something. Sometimes it doesn't work. It's not best practices when it comes to packet tracer, but it's worth trying. So exit. Alright, show run. Okay, so show run shows all of this. So I want to copy all of this and put it right here. Okay. And I just modify some things. Alright, so we need to add a nut shot here. Nut shut down. Nut shut down. Okay. Then we're gonna add an exit. And it's gonna apply the default gateway. Okay. Line console. Okay, then with the Y and N. Alright, so let's modify this for our second switch, which is cells. It's gonna be 130. And instead of 128, it's a /26, and /26 is 192. The default gateway is a 129. Okay. That looks about right. Alright. Let's repeat that for switch 3. Same thing. We will modify the name. And the IP addresses. That's going to be for IT, so it's going to be 93 is the default, 92, and it's a /27, so it's a 224. So instead of 130, it's going to be 194. /27, so it's going to be 8224 for the subnet mask. Okay, not shut down, exit. The default gateway is going to be 193, and everything else should stay the same. Okay, copy that. We're gonna apply that configuration. Okay, so okay, I know that we're missing something here, because the service password, I don't see in the configuration this requirement right here, encrypt all plain text passwords. I do not have that. In my configuration, so if this is the case here, then that should be also the case on switch 2. Okay, so terminal service password encryption, and we will have to do the same over here on switch 3. Okay, so service password encryption. Alright, what else are we missing from this configuration here? Configure the console Bitsinthewire lines after 5 minutes. Disable DNS lookup, configure the default gateway, configure Bitsinthewire and subnet mask according to the obvious table. Okay, so the PCs looks good. Alright, so missing something on my configurations. Okay, so if we check the requirements, what is it that we're missing? Probably forgot something. Oh, we didn't, on the switch 2 and switch 3 we didn't apply the not shut down, although I did put that in the configuration for the VLAN interface. I did apply the not shut, so I do not know, as you guys can see. Alright, so interface VLAN, put the address, put the not shut down statement right there, and then exit, because I was inside the interface VLAN, so it should, but packet tracer is a little bit weird. Okay, but everything went the way it was supposed to go, so that's a no big issue. The configuration was correct, the methodology was also correct. It's just packet tracer. So interface VLAN 1 not shut. Okay, you should have taken that command from the configuration file. Interface VLAN 1 not shot. Okay, so that should have, yeah, and it did. So you guys can see it's 100% completion. Alright, so we can also go ahead and test connectivity, but we have completed our configuration. Just to prove it, we're going to try to connect to the server. So let's see, from the IT computer, let's go over to the web server. IPv4 working, that's good. Now let's try again with version 6. And it's going there too. So that seems to be working just fine. So there you got it. There you go, folks. I hope that you guys have enjoyed this, and hopefully it will help you and it's useful for you. This is for the last challenge in Packet Tracer. So hope it was helpful for you guys. I'll see you in the next one.